The most common question I get about people going into space is about why are they weightless? Doesn't the force of gravity still exist in space? And the answer is, of course it does. Without it, the Earth would not orbit the Sun, and the Moon would not orbit the Earth. But yet we see all these pictures of people going into space, and they appear to be drifting around as if they don't weigh anything. The reason for that is their motion. How objects behave in what's called orbital motion. And this lesson is going to attempt to talk a little bit about orbital motion. Then it's going to talk about the devices that enable us to achieve it, and kind of the dual purpose spaceflight and military purpose of this technology. You can model all of this with the little demonstration I'm doing here. You can see I'm kicking two angry birds off the desk. And the red one I'm pushing, the blue one I'm pushing faster. And you can see the difference in the shape of their flight. The red one falls down, follows a parabola. So does the blue one. But the blue one's parabola is wider. You can imagine me throwing these things faster and faster. And the arcs would get wider and wider and wider, until eventually the bird would hit the wall of the classroom, traveling almost parallel to the floor. Newton realized that if you could take an object out of the constraints of the world, if you went up on a very high mountain so there was no walls, and you could throw it very hard, that something really interesting would happen. As these arcs got wider and wider and wider, the Earth would start to curve away from the falling object. Now, these paths are not parabolic because the force of gravity is not always straight down. As you start to go around the Earth, the force of gravity always points inwards. But the idea is kind of the same. The harder you throw it, the wider the arc. And if the Earth starts to curve away from it before it can hit the Earth because you're throwing it faster and faster and faster, at some point you're going to throw it fast enough that the Earth's going to curve away. And it's just going to keep going. Never getting closer to the Earth because it's going so fast that every time it would fall towards the Earth curves away. And you'd go around and hit yourself. That's what's called orbiting. So, to make an object orbit, you have to make it go very, very, very fast. Thousands of meters per second. So, how do you do that? Well, the only way we really have to do it is to use a rocket. Something that puts such a tremendous force on an object that it can travel so fast that by the time it gets far enough away from the Earth, it's traveling so fast that even though it's falling, the Earth curves away from it and never hits. This is why the astronauts in the International Space Station look weightless. It's just like when we talked about elevators. The reason you feel like you have weight in an elevator is because the floor is pushing up on you. If the cable was cut, the floor would fall away from under you at the same rate you were falling, and there wouldn't be any normal force. So you would feel weightless in that elevator too. The astronauts in space are just constantly falling towards Earth. But let's take a look at what gets them into space. And let's look at the very first rocket that put a human into space. And that was a Soviet missile carrying the Vostok 1 craft. So this is April 1961, and Yuri Gagarin is perched in a spaceship under this nose cone up here. He's about to become the first human to go into space. This is in Kazakhstan, in the old Soviet Union. The spaceship looked like this. There was a ball-shaped crew compartment, and then all the mechanicals of the spaceship were down here. It was going so fast that, like most spaceships, to re-enter, it had to have protection from the friction it would experience with the Earth's atmosphere, and only the ball-shaped parts survived. This nice big window wasn't part of the ship. This hatch was over there. It's just there so you can see in. But this is the world's first spaceship. It still exists, and it's sitting in a museum outside Moscow. And that's the place where humanity first left the planet. And here's Gagarin sitting in it. So let's look at the American response about a month later. We too launched someone into space. And this is Alan Shepard's Freedom 7 capsule on display. This is the first American in space, Alan Shepard. And here's the capsule being recovered after the first flight. And here's a picture of the missile that launched Shepard into space. And you can see he's sitting in Freedom 7, which is on the nose of this missile. I'm using the word missile very carefully here because it's important to understand that these are missiles. And the Freedom 7 missile, the Mercury Redstone missile, is really worth taking a look at because it's literally the same missile as this one, which has a nuclear warhead on top of it. If you want to make someone go so fast they orbit the Earth, you have to put a tremendous force on them. And that's exactly what you have to do if you want to deliver a very heavy nuclear bomb to something across the world. And it's the exact same device that does it. That's what makes things go so fast. And that's why when you hear about countries with a space program that people feel threatened by it, it's because to develop a space program, you also have to develop the kind of missiles that could deliver nuclear bombs. And that's a source of tension in the world as different countries develop that capability. And it's a major thing to understand when you are looking at the history of the space race between the US and the Soviet Union, that as they were developing these technologies to put people into space, they were developing the same technologies to deliver bombs to each other. It actually goes back to the very beginning of our explorations in space. This was the first ever photo in 1946 taken from space. It was taken from an American V-2 rocket. And the fact that it's an American V-2 rocket is a little bit of a strange thing to say, because the V-2 was a feared Nazi weapon from World War II. This is one being launched from Peenemünde during World War II. And they were designed for one thing, which was to destroy London. And they did a pretty terrible job on London. They caused a lot of suffering and killed a lot of people. But they were so powerful that immediately after the war, the United States swooped in and basically seized everything they could from the program, and including the chief designer, Wernher von Braun, who became the chief designer of the American rocket program and helped put Americans into space and later on the moon. And he was the designer of the V-2, which caused so much trouble during the war. So it's important to understand that when you're talking about going into space, you're talking about tremendous forces, and forces that can be used for both good things or bad things. And that's why the history of spaceflight